So in this lesson, we're going to look at line of best fit for bivariate data. I'm going to use the data in example 1 from your notes on bivariate data. So once again, from the menu, we're going into statistics, and remember how to clear any data you have. I'm now going to put in the data from the question. So we had shoe size, and I'm going to put the shoe size into list 1. So 2, 4, 5. And I'm just going to pause this recording because you don't want to see me type in all these values. Okay, so I've now got all the shoe sizes in. So in list 2, I'm going to put the reading ages in. So 8, 7, 9. And again, I'm going to pause while I type the rest of those in. Okay, so all the data is now in. Now we're going to look at calculating a line of best fit. So to do that, you go to Calc and we go to regression. There's lots of types of regression. The only one you need to know about is the very top one, linear regression, which will produce a straight line. We put our x's, that was our shoe size, and note in your example that the shoe size is on the x-axis of your graph. So that's in list 1. The y's are in list 2. Frequency, just leave that as 1. The copy formula, I'm going to put that into Y1, and we'll go and have a look at that shortly. You don't need to worry about residuals at this stage. You will need to worry about those possibly in year 12. So that is that. Click OK. Now notice at the top here it says y equals ax plus b. But down here it tells us the value is 1.16 and that the b value is 4.98, telling us that our straight line is y equals 1.16x plus 4.98. You just substitute these values of a and b in here. Tells us some other things. The R tells us how well correlated the data is. We'll have a look at that in just a second. Don't need to worry about these other values just yet. So if I click OK, look what happens. It gives me the line of best fit, but also the scatter diagram. Now that R value of 0.8 tells you that the points are quite nicely fitted to the line. A smaller value there means the points will be more spread out around the line. A much higher value, closer towards 1, would mean the points will be closer to that line. But while we're here, let's go to analysis and trace. That puts us on a point here called the mean point. It's the average of the x values and the average of the y values. But you can use this to go and find out other points along the line. So if you are interested in the y value when x was 7 maybe, then what you could do, if you just click a 0 here, it brings up an enter value, and we'll just get rid of that, put 7 in there, and it moves that point and it gives us x is 7 and it tells you what the y value is there. So you can use that to find the y value for any value of x that you're interested in.